So Marley's joined us all the way from Redmond, Washington. This one's close to my heart because I actually went to high school and university in the Seattle area, and spent 10 years of my life at Microsoft. So I have a definite affinity for this. But many of you probably know Marley. He is a very well-known persona at Microsoft around blockchain. We have been doing a lot of things in partnership. So Marley is going to talk to us a bit about what they're working on, DLT, in the cloud. So obviously, the cloud being Azure in this case. So
hope you guys aren't sleepy, because this could get boring. So I'm going to talk about Microsoft, what we're doing here. And I won't spend too much time doing any introductions. I won't leave a lot of time for questions. Looks like most of you will probably have lots of questions. So quick agenda. We'll roughly stick to this and try to get through as quickly as possible. But we'll sort of give you a mindset. Some people always, when you talk to architects, they want to kind of know what your motivations were. So they don't want to make assumptions. Then we'll talk about our layered approach. And then I'll break down sort of what we're doing at the two layers that we're focusing on at the moment. And then talk about some of the surrounding capabilities. Some of them are working with R3 to sort of really make distributed ledgers pop, if you will, in the enterprise. It's an awful lot of hype to live up to. So we need to put some, glitz in there. So let's talk about context. Most of you probably have this conversation with people that come, line of business people that come to you, or somebody that wants to know what blockchain is, and you struggle, and you explain it to them, and they come back to you and with a brilliant idea that they think it is a centralized database with a web front end, and that's the best solution. Like, that's really not what we're looking for. So you just try to talk about, say, all right, how do we go from hype to understanding what the essence of what we're trying to do is? Most of you probably already know this, so I won't go too long, but I thought you might want to see these because these kind of land pretty well with people. So we say it's all about trust between ourselves and us, meaning us. And when you say people like that, you're saying, it's multi-party by default. If you're trying to build a blockchain within your trust zone with one company, you probably ought to use something else. Distributed system is probably not the thing for you to use. So how do we establish trust between us? To transform the way we exchange value with each other, and you can go into the whole what is value and all that good stuff, but we do this by establishing a shared truth, in this case, based on cryptographic proofs, which is our ledger, to revolutionize the way we're going to work together, and it has the potential to really be disruptive, so we usually make it say forever. Drop the mic, leave, you're done. So then we say, okay, well, it's really a two-step tango. People have been so enamored with the word blockchain. I remember it was back in 2016, I was doing a big event, and I was trying to say distributed ledgers and change the terminology. And one of my peers in business development, she said, hey, you're wasting your time. And we had a little competition, and we said, I'm going to call my sessions. It was a big public Microsoft thing with partners. Now, I'm going to call mine distributed ledger, whatever, and you'll call yours blockchain, whatever. Mine was super technical, you figured I'd get all the millions. I had this room with 500 seats in there. She got the little room. She used the word blockchain. She had to do 3 extra sessions. It was the fluffiest content ever, too. I had like 10 people in a 500-person room because they used the word distributed ledger. So don't fight the hype. Just, it's a blockchain. Not really. So anyway, we talk about shared ledger or shared truth. Essentially, we're talking about, this authentic persistence. We all know this stuff. So Corda does this. Most blockchains aspire to do this thing. We call this the representing of the truth. It can be historical truth and truth at a snapshot in time, during a state of where your contract is or whatever you're trying to do. It's represented as truth in the ledger. If it's not recorded in the ledger, it ain't true. Simple. But that's not enough to establish trust. We have to trust in the resolution of that truth. So that's the second step we have to have. And it's not just good enough to say, hey, it's in the ledger. Well, prove to me that you did what you were supposed to do. And nobody's trying to pull a fast one on me. So this whole cryptographic proof thing, how do you prove something with somebody you might not know? So in a public or trustless network, this is a sticky problem. So what did? They said, okay, we're going to put our logic on the blockchain, and we're going to run it on the blockchain. You want to trust me? Here's the code. Look at it. And the code is law. Anybody heard that one? That worked out really well, right? That's a learning experience. But that's a fundamental architectural problem for traditional blockchains where you're running code on all the nodes and you aspire to scale to something more than 5 transactions per second, which is pitiful. So we say, well, let's introduce this new concept. It's brand new for you young developer. This is called separation of concerns. You might want to separate your data from your logic. You can version them and scale them differently and all that good stuff. So we said, okay, these are big concepts. I'm not going to spend too much time here. So what is Microsoft's layered approach? First, we said, the first thing we want to do, and this is how I got started in blockchain, was I pulled my hair out trying to install a private Ethereum network. When Frontier first came out, like the day you could get stable bits, I was like, all right. I spent a weekend. I set my hair on fire and ran from the building almost. I was in New York City. That wasn't a good idea. But anyway, it was so hard. So we created blockchain as a service to make it easy for people to fail in private. Because as an architect and previous developer, still doing a lot of development, I don't like to fail in public. Because I learned by failing to ultimately get to success. Most of us do that. Most people don't really succeed the first time you try something. If you do, you suck. Anyway, so we said, okay, let's figure this thing out. We've since evolved and said, okay, how do we let people start to build things with this? So we said, well, let's go approach this in a layered approach. Let's follow separation of concerns. And let's do things like scaling and developing tiers differently. There's different skill sets. I mean, the DBA role, database administrator role, was invented when client-server technology rolled out in 3 years. There's no such thing as that. Now I think it's being revived a little bit, but there's a different skill set from the development of creating schemas, and there's a different skill set for people that don't create schemas. And they worry about serialization in the classes and that kind of stuff. So we want to have that kind of separation of concerns. You have flexibility in design. You want to be able to put things where they make sense for your use case. As an architect, when that first approached blockchain, you had both hands tied behind your feet and your shoelaces tied together. You didn't have much choice in how you were going to do things. So anyway, we have a lot of things here. We can use established enterprise technology because we need to be able to use that stuff. Make a logic portable, lots of these separation concern things. So let's split these things up into 3 logical layers. This looks familiar. 3-tiered architecture, 3-layered ledgers down at the bottom that do ledgers really super well, and they can be indexed for their functional and non-functional needs, and customers can pick the right ledger for the job they're trying to do. Because no one ledger is probably going to do everything. Ethereum is a really good general purpose ledger, but it's not going to do everything you need it to do in certain circumstances. And vice versa, so we need specialization. Logic, I called these things criplets at first because I have a long J2E background. It just made sense to me. But now that marketing got a hold of it, they're called enterprise smart contracts. I'm not going to fight that battle. But it's logic running up here. And then existing systems. That includes user interfaces, ERP systems, whatever, integration point. So let's talk about the optimizing the ledger. Again, how blockchain as a service got started, which I still take heat for calling it that because it's really not a service. It's really just automatic deployment. But we've nailed this. I stood up and I felt good about establishing a single node network. We're now automatically deploying multi-node, multi-member consortium networks on just about every major platform that we have out there. So we made it sort of ridiculously easy to stand up these blockchains. And most of you probably built a reputation of being able to install a blockchain and get it 2 nodes talking to each other. You're like, yes, it's time to quit. And now you're like, okay, well, I did that in 10 minutes. What do I do with it now? So we made it ridiculously easy to roll these things out. The next step is obviously to take it forward. As a DevOps person, you want to have, okay, I need to manage this. We just automated the deployment. But once it's deployed, you're on your own. You got to patch it. You got to manage it. You got to monitor it. So we're going to say, well, we have this rich management platform called OMS. We want to extend that. And not just to nodes that are running in Azure, but essentially all your nodes. You could look at, and a blockchain is unique because ownership is very much democratic. We don't want you managing somebody else's nodes just because they're in the same network. So we need to figure that out. You want certain visibility across the network, the ability to actually tune and perform the resources that you own in that particular network. So you'll see us moving in this area to give you rich tooling, alerting, all the enterprise features that you're used to having your, as a developer, the DevOps people will do that. I just plugged in the APIs. But they're going to have those tools for them. Most of you heard about Cocoa. Anybody heard about Cocoa? Okay, R3 was on her. So Cocoa was launched end of July or early August, but essentially it's an effort to, in this audience, and Corda doesn't really make too much sense, but if we look at what it's trying to do, it's using TEEs, which is, most people think of Intel SGX, which is what's in silicon, but there's other enclaves out there. Everybody has an enclave on your phone, for example. Your trusted or your secure element on the phone is essentially an enclave. So they're pretty much everywhere, but it allows you to, this framework will allow you to run the same code, say blockchain stack or a distributed ledger node within this enclave securely. So we know everyone's running the exact same code and no one can spoof it. And then we establish a level of trust where we can use lighter weight consensus algorithms and not have to do these heavyweight consensus algorithms to really boost performance. Now, in true distributed ledgers like Ethereum, this is a huge benefit. But for some distributed ledgers that aren't architected that way, you may or may not, you probably find other uses for this. But you could build essentially anything. You can, you could essentially build, well, here's some of the things that it does for you, out of that it aims to do for you, but it introduces a governance model, like who can join your network, confidentiality, because each node can also hold your counterparty keys. You can get into things like ring signatures. You can do threshold encryption to keep things private. You can secure node-to-node transactions. Consensus is where people look at and say, oh, this is really going to boost performance. But it's agnostic to really what's running inside of it. It's just sort of the plumbing that you would use to build sort of any type of app. So when you look at, is Cocoa the right thing for me? You say, okay, am I running the exact same code in all the computers that are going to run Cocoa? If that's yes, then yeah, that's a good candidate. Does it need to be secured and governed? Meaning you're not just going to let willy-nilly people plop nodes, even if they have the same code on your network. What is it there? So you can essentially build a secure BitTorrent using Cocoa. It doesn't have to be a ledger or a blockchain. It could be essentially anything. So it's a framework. We call it the Cocoa framework. Distributed ledgers just happens to be one of the best use cases. But we think it's going to be used for a wide variety of things. And Intel was here earlier, so we think it's going to be quite useful. This will be open sourced. It's not been released yet. We're going to get it to a certain point where it's actually useful, and then it'll be open sourced, and pull requests can happen at that point. So it's still early days. You can't actually play with it yet. That'll happen a little bit later this year. What I really want to talk about is what you can actually start to do pretty close to now. We have some customers actually doing some of this right now. And this is what I'm calling sort of, the first name I called is distributed multi-party compute, which goes over most people's heads. So now I'm trying out consortium compute, which I'm sure marketing will take and slaughter soon. But it's really a mind shift for most people. Most people think about applications, and even though they start thinking blockchain, they're still thinking single-party execution, and they don't think about how the applications are run. It's that whole shared truth, but also you need shared resolution of the truth, or at least proven resolution of the truth and allow it to be run on separate tiers. So we talked to a lot of architects and have built like web applications for years. And I've been doing 3-tiered since you were in diapers. And I'm like, no, you weren't. But anyway, it's different than typical B2B and commerce solutions where you still have separate trust zones. We're actually saying we're going to run the same code in the same environment. We're actually going to receive a lot of benefits that I'll talk about here in a minute. So the smart contracts is where this really got introduced, where a lot of the enterprises got super interested. So you want to share your logic. Ethereum, like I said, public networks, it made a design choice because it was trustless. It really had no other choice at the point in time. Now with private networks, where you know who your counterparties are, and you have other legal recourse means. If somebody tries to do a DAO event in one of those networks, the cops will show up. So we can start to do things and not architect things based on assumptions that aren't true. Corda's approach is different. It's not broken. Like I say, some of the things I'll talk about here from the benefits will apply broadly to blockchains, not necessarily distributed ledgers, because their execution model is, let's say, more enterprise-friendly. Shocker. But anyway, there's still some benefits I think you might be able to derive because it does give you this flexible and extensible extension of this trust envelope from your ledger. So let's talk about the distributed DLL. Shameless plug for Corda. So down at the bottom, we're going to draw our stack from data up. So Corda, and then we throw in all these others. So one of the first points is we want to make our middleware agnostic. Should be able to work with anything. So above our blockchains, we have this abstraction layer, which is essentially a transaction router. These ledger adapters are basically the only blockchain-specific or ledger-specific, platform-specific bit of code. It's got a standard pluggable API, so you can write a ledger adapter and just plug it in. I mean, it is a simple API. It is a well, I don't have to go into the API. If you're interested in that, you'll see the documentation soon, but it is very reusable. We've been doing abstraction layers for decades. If you've ever built one, you'll see the same pattern. You go, oh, I know what you're doing there. Above this, we have our shared execution environment, where you'll see the thing here I try to really stress when we say this is our, this is where we execute our logic. So think of this as the playground. We show up with our toys and we're going to play together. And you can take your toys and go home if you want to. But the contracts are between counterparties, and we have a more discrete trust model up here. So when counterparties come up here and run code, contracts, but it's not just contracts. We also have traditional what we would call oracles. We call them utility criplets. Because Microsoft, we can't call something Oracle because it's a competitor. Marketing got a hold of that one too, and lawyers got involved. I was like, okay, I won't call it that. I didn't make it up. Anyway, so you start to see we're bringing counterparties together in a shared execution environment. And down at the bottom, we have this thing called a proof engine, which most of you know. We're generating cryptographic proofs. And these cryptographic proofs are essentially native to most of these ledgers. But you can also do lots of cipher diversity. You can have proofs upon proofs. If you've ever done a certificate chain, we have defense in depth like that. We have the same notion. They're called onion rings, or crippled onion rings. I'm getting hungry. All right, so anyway, we have the proof engine. Above that, we have a standard messaging API. I saw AMQP earlier, same thing. So it's natural to plug in here. We put REST, RPC, because of the community. They're all about, hey, I'm doing RPC. I'm like, dude, that's not really enterprise. How do you get through firewalls and stuff? How do you do guaranteed delivery? I don't know what you're talking about. Never mind. You can put an RPC there. Just put it in front of the message bus. On the side here, we have data services. Like in Azure, you have limitless data services. Key management, this is the one everybody loves. Key management and identity. These are the two we combine together that most people are like, God, if you can take care of that for me, you just solved most of my problems. And the good news is we are going to provide that for you. So this is it in general. Let's get a little bit more specific. So as we come down here, we'll start to see the specificity. Azure Service Bus, AMQP, strongly typed messages, serialization frameworks, up to you. I heard the same discussions, a lot of the same things. You're going to have the same sort of questions that you'll have there. I put RPC REST kind of where it belongs. And then Azure Active Directory, if you're not familiar with Azure Active Directory, Active Directory is the most widely used enterprise identity system. Azure Active Directory is a federated cloud system, so you can federate to Facebook IDs if you want to, which we map to keys that we can persist in Azure Key Vault, but you can also bring your own HSM, and in the next slide I'll show you we actually expect that to happen. But the whole providing a common authentication layer, mapping to secrets is pretty cool, and be able to manage that and do things like key rollover and all that good stuff. Data services, this is going to be big. We just don't know how big it's going to be. We've never had the opportunity to get cross-organizational data views like this, and especially when some of the data is encrypted and not. And then we can plug in super cool things like Event Hub, which is this massive parallel eventing framework that sort of fire and forget, built for like IoT and massive number of events. We can plug into that. We can pump transactions to it, and then anyone can subscribe to the, well, not anyone, but you can plug a SQL Server or NoSQL or Cosmos DB on the other side of this guy and ingest transactional data, and then you can reason over it with machine learning or any sort of analytical tool. So this is, now here's the secret sauce, okay? Let's drum roll. And most of you are thinking, but how do you do this? How do you do that? Hopefully I answer some of those questions here. So now you're back to what we do support multiple chains, but this is another shameless plug. There's a Corda down here at the bottom. Same diagram, essentially. I just had to make room for the next bit. So we have Azure Key Vaults or multiple HSMs. Remember, it's an us or a we place, meaning it's going to be big banks coming together. We don't expect big banks to use the same HSM, just like we don't expect your secrets to be in the same memory address space, that kind of notion. So we expect that you're going to have multiple HSMs. We have a proof engine. Now this is where the cool bits come into play. If you've ever built middleware or consumed middleware before, one of the things you do in middleware to allow you to scale is you pool scarce resources or expensive resources. So we did this with databases when we went to the web. If we had an Oracle backend and we only had 100 licenses, we needed to scale to 10,000 users. We pulled our 100 concurrent connections together to allow us to scale to 10,000 users. And Oracle tried to figure out a way to charge us for those 10,000 users. But anyway, that's a different story. But you pull these things. We're going to do the same thing with enclaves, FPGA, ASICs, whatever, any sort of accelerant that you might use to create some sort of proof. So enclaves, obviously, we're using to have our secrets placed in, and we can do ECC signatures. We can do all sorts of interesting things. But FPGAs could be used to accelerate zero-knowledge proof generation. You might come up with some sort of whiz-bang proof that requires, we had one customer, I was telling you guys this yesterday, they said, I need a GPU, FPGA, and an enclave, and I'm going to combine this thing. Can I do that? I was like, well, sure. You can define your own sort of proof delegates and then ask for them. Essentially, you're not asking. In your Cripple, either in your metadata or you can ask accelerant in policy, you can specify, hey, my dependencies, I need an enclave when I run. And when the container boots up, it says, oh, this guy needs an enclave, or he's going to run in an enclave. It gets one out of the pool. You run in the enclave, you use it, you're done, you return it back to the pool. So we're pulling these resources, and this is sort of that magic bit that allows us to do this. Now, there's a lot of things. You can't do this exactly today. I'm showing you sort of roadmap. This is actually, but this is the model that is going. We're doing it with enclaving right now. We don't have too many people they're just starting to do FPGAs for zero-knowledge proofs in the cloud. But we think it's going to be pretty impressive. We're essentially allow you to pull any type of resource and be able to pull it into this runtime. So here's where the enclave gets. Enclaves get injected, essentially, with the secrets at runtime based on what the Cripplet needs. If it's impersonating or signing on behalf of someone, it can do that. Or you can fetch these things and return them. So let's talk a little bit about Cripplets. We think initially Cripplets will come in two basic types. Right now we're running them in .NET or JVM or native. You can write them native if you want. Most customers are just happy to do stuff in Java or .NET and do that. But you can write utility Cripplets. These are ones that are not contract specific. These are oracles. But you can do a lot more with these things. You can go out and get market data. You could also tie into events that might happen in the enterprise that you need to plug into your ledger. So it's essentially, you can do anything and then you can attest to that. And the proof engine will provide you the infrastructure without you having to write the code for, I got to sign this transaction, or I got to encrypt this thing. And infrastructure will take care of that. You just worry about the logic of either going and fetching your data or publishing your data as well. So you could set up pub sub models as well if you needed to publish, say, market data into a contract every 5 minutes or something. You could do that. So it's really flexible what you can do here. We expect these to be, they're horizontal in nature. They can be scaled out. So we can just create many instances of these things, and it will happen dynamically for you unless you set a threshold based on licensing. So you might create a library of these, put them in the Azure marketplace, and sell a license to somebody that they can create 100 instances of these scaled out, but each one can only serve 10 clients at once, and the billing will happen. So we expect there to be an ecosystem of our ISVs, and even our customers will develop these libraries. They might say, hey, I can make money off this. Somebody else will use it. Or you might just share it within your consortium. Anyway, contracts are different. So contracts would be things that would typically represent a contract. So this is one for like the Ethereum networks where smart contract execution is broken and you want to pull all your logic out of the blockchain. You want to run it everywhere. You can use a contract Cripplet to do that. These things will allow you to, we have three different models there that they run, but essentially these aren't scaled out. Depending on the use case, if it's a serialized use case, there'll be a singleton, but you can do pairs and rings of these as well. But they use the same infrastructure. The difference is one is sort of, you can think of as multi-tenant, the other is single tenant, if you will. So some diagrams that we have here, these are, the framework down here is this sort of the container. There's actually a container it runs in. A single pipe, and because we're using messaging, strongly typed message in, strongly typed message out. Those messages are always signed on the outbound. They are optionally required to be signed inbound. Most of the people that are building this now, they're not signing anything. They're just, anyway, but it's an option for you. But the Cripplet container runs, they're specific to what the runtime is, like if it's .NET or it's the Java JVM. And then, so most customers aren't actually choosing to use the enclaves. They're fine just writing their code in enclave, because the enclave right now is fairly restrictive. Like you can't run a full .NET framework in an SGX enclave today. You can run a stripped down version of it, but even then you're sort of hobbled. So we have lots of customers that are just using the enclave as a signature delegate. So I'm going to run my code in .NET Code, and when I have a signature delegate that I've received when I was instanced, and when I need to sign a payload, I give it to the signature delegate, and it signs it for me. But I don't actually have to sign that, regardless if I'm using a signature delegate or I'm running in an enclave. I still don't sign it. All I do is create my payload and send to container, and the container takes care of everything. And you don't have to write that code. It's a very flexible design. We let you pick and choose and have cipher diversity. So you can, at this level, you can sign with ECC or elliptic curve, RSA. You can do whatever you want to. So you can So your actual payload, if we take a look at this, I go through this the standard model. So if I have a Cripplet that's running as a utility, it will sign its payload with its Cripplet private key. So it signs the payload there. So if it's just a price, let's say it's a 4-byte message, it gets signed, and then it will get signed by the enclave, and then the enclave will pass it down, and it will get signed by the connector for once it builds the blockchain connector, and then that's also signed by an enclave optionally. You'll have to strip that out if you don't have an enclave on the other end. But anyway, it can be signed in multiple layers, and then you can choose, depending on your platform, how many of those proofs are going to persist on your ledger. Most blockchains require that digital signature just to get the transaction in, but you also have the other proofs that can go along with it. You could choose to persist at the ledger level, or you can pump them out to a sidecar database, your choice. But you could have as many layers of signing and sign all along the way. You can have like 7 layers of your onion. Anyway, so very proper abstraction. We are abstracting away currently. You can use our VSMs. These are hypervisor-based enclaves. Those are the ones that we're using if you're playing with I don't think there's anybody that's playing with it right now, but they're VSMs. They're not actually SGX. But the API is the same. We have abstracted away so that you really don't know. That you can declaratively say, I require an SGX enclave, and the infrastructure will give you one. But if you don't, it's just going to give you the cheapest one it has, which happens to be a VSM. So, all right, so let's go to the surrounding capabilities that we're looking at Azure. And this is just a short list of them, and I'm going to cover every one of these. Anyway, I don't know what this digital twin is, but I think I know what it is. Anyway, I'm not going to cover all these. This is one of Scott Guthrie's slides, and I noticed that he put the word blockchain in there. I was like, oh, man, it should be distributed ledger. Don't you have any chops? Anyway, so let's narrow it down a bit. The first thing every customer wants and platforms want, give me identity. I need an identity solution. This is a pain in my rear end, and enterprises have solved this problem. We have single sign-on capabilities, right? Let me leverage that. Azure Active Directory is a great solution. We just sort of backed into that one. But the federated identity, you support things like single sign-on. And then the infrastructure will take care of that, map it to your keys, and away you go. So the combination of Azure Active Directory with a key vault is tremendously powerful. I haven't talked to any customer that isn't like, yes, I will use that, please. Then the other one is big, and this one's the one I sort of struggle to hype enough because I really don't know what people are going to do with it. But data services, when we get this data lake, and you get these networks running in production, and you're throwing a whole bunch of metadata and of the transactions over into these data lakes, who knows what we're going to learn? I mean, I'm not really sure. Like a public Ethereum network, the visibility that you can get from like the Bitcoin network or the Ethereum network by just sucking this stuff into a data lake and turning artificial or Cortana analytics against it and say, tell me what you know about this data. And we'll see. I mean, we don't know. In an enterprise context, it's different because we do have privacy and things like that. You'll probably only be able to noodle over your data, or in this case, the data that makes up your composite ledger, to see patterns, pick up higher level fraud, see optimization points, that type of thing. The good news is this stuff is sort of off the shelf, and we're working with lots of our platform providers to plug these things in so that you're just turning them on, and you can use those things and really get that better together story when you don't have to run your entire blockchain or your entire distributed ledger in the cloud, but you can just connect up to it to start to harness and leverage some of this scalable power. That's pretty cool. Couple of key points that I forgot to point out. When we go back to the shared, the us and we scenario, This is the cool part. Come on. So when we get to this model, without this model, usually what happens is people, they share, you put your distributed ledger or your node for that blockchain on, and you bear 100% of the cost of the nodes that are maintaining that network as you run them. And then any apps that you're running, you're also bearing 100% of the cost of the infrastructure that requires you to run that application. When you start coming together into this us or we environment where you're coming together and you're meeting counterparties, ask and bid and market making here, and executing your logic here, you can start to do things like splitting the check. Because we know who you are, and you can then, instead of everybody bearing 100% of the cost to do, but only deriving 50 to 25% of the value, you can flatten that economic model down. This becomes very attractive to people that are writing the checks for this technology, and that you'll get more efficiencies in ability. Now, we're not there yet. That changes our business model. We just went through this huge revolution from a licensing-based to a subscription-based system, so it's going to take us a while to get there. So let me get to the roadmap and tell you what you can do when you can expect to be able to do some of this stuff. Get back to this slide. See if I can keep from. All right. So this is my roadmap slide. I can't share roadmaps anymore. They don't let you with dates. You never share that anymore. So what can you do today? Deployment, you can do that today till you're blue in the face. You can deploy 10 networks in an hour, and you can delete them in 10 minutes. It's easy. So that one's pretty much check. It's going to get better. There's things that we can further automate. So people always have to try to improve this. Management is going to be sort of a regular cadence. Just getting the first management pack out is sort of a challenge for us because a lot of this stuff is running on Linux and it's open source. But we've already got those hooks in there, so that we'll see this management come, and then you'll get regular updates. So if you're not an Azure customer, Azure updates roll. There's not these big releases. They just kind of roll. You get quarterly. Depending on the service, you might even get faster updates if you sign up to particular services. So we have rapid updates there. Cocoa, it's going to be a while. That's, again, in joint development, Microsoft Intel, R3, has some, as we go through, we'll get that to a certain point where you'll be able to play with the preview bits, and then eventually it'll be open sourced to become more and more useful. But it has to get to a certain maturity before we open it up, or it'll never get off the ground. Enterprise smart contracts, Criplets. We have customers that are using this in private early adopter. We're working as hard as we can. The demand has been overwhelming. Just for doing Oracle stuff has been pretty overwhelming. It's not the revolutionary kind of stuff we're talking about, but we have a lot of demand for that piece, and we hope to get it into your hands in developer preview this calendar year. I'll say that. I said calendar. I didn't say the actual year. I wasn't talking about specific. It was a calendar I saw on the wall. I don't know what it was, but it's calendar year. You potentially could get this in your hands. So with that, this is sort of the summary. What we're trying to do is we're meeting our customers where they are, and providing them. We're going to shift if we do have strong partnerships like with R3. We have always had a strong partnership with R3. They were like, we came together and sort of got this thing started, and we have a fondness for them. But we also have to support like Fabric, which we do, because our customers want Fabric and they want chain, and everyone wants to try with Ethereum, and it's like sort of you got to go write a passage. You got to do that. And don't get me wrong, I sit on the board of Enterprise Ethereum, so it's good. But anyway, we want to have the true hybrid, things that are principles. It's going to be open. We're an open cloud. We're going to open source as much of it. As soon as we get to the point where we can open source it, it'll be open sourced. And then integrate with your existing systems. This is where the real value is for enterprises, particularly around identity. We talked about that one. And then we're going to keep pushing forward, doing research and security. We're doing things with formal verification of contract code, language, domain-specific languages, runtimes, security, We're going to continue to invest and pump this back into both our platform and into our partners' platforms. And for those of you who aren't familiar with Azure, we are, I think, in 39, might have cracked 40, I have no idea, in regions, and we just continue to grow. The number of, these aren't data centers, right? There's more than data. Each one of these represents just a region that we cover. So we pretty much have everyone covered at this point, and we're starting to add more and more where we see key workloads to keep growing this network. So with that, I'll stop. Do we have time for questions?
Yeah. Take awesome. Questions? Who wants to go first on questions? Not good. I get to actually throw it this time. There's a reason I went in technology, not baseball.
Cool.
Oh, it worked.
Should have been a football. Oh, we're not in America. It's a soccer ball here.
What are the roles of, in your opinion, of smart contracts and core apps now with criplets?
Sorry, I missed the first part.
What do you consider as the role of smart contracts and core apps now that you've got criplets?
Oh, I mean, flows, core apps and flows, that execution model is not broken, right? I think criplets could be a good external Oracle interface, to get stuff, a framework to be able to provide attested data. Because you'll start to see when Oracle providers like, say, market data providers figure out that, hey, they can write one criplet and it'll work across all the distributed ledgers, they're going to flock to that, right? So you'll have a richer set of off-the-shelf capabilities that you can grab. So I think that's going to be an attractive place where we'll get some scale from a marketplace perspective. But other than that, I mean, I think a lot of the things that we see in Azure for Corda are the obvious ones: identity, key management, the data services are those. So hopefully that answered your question. Wait, hang on. I got to throw you the... What is that? Okay.
Where do you see the most activity in terms of deploying Corda, Quorum, Ethereum? Which ones are the most popular at the moment?
Oh, it's Ethereum by far. It's just because so there's a difference between installs. So we have installs and people will spin up networks, but then they go away. As far as what we look at is sort of like stickiness, and like if somebody just installs a network and it stays up for a while, we're seeing Quorum will stay up a little bit more. Corda obviously will stay up a bit more as people start to build actual systems that they aren't just doing a hackathon with. I mean, we have a lot of that. We'll see like a weekends, like there'll be like 4 hackers. You can just pick out the geographic. Oh, they're doing a hackathon. Yeah, there's a bump there. But it's still early because there's nobody really doing much that they're saying about production. So it's going to be really telling. But as far as just pure developer community and people going out and self-serving, grabbing a free Azure subscription and newing up something to build a network. Like I said, if most of you probably the first thing you did was do Ethereum. I know even our 3 guys, they did Ethereum because it was the only game in town at the time. But once you get past that, when you start to specialize and say, what do I really need? And that's where we see people go into Corda and we just want to make sure from an Azure perspective that experience you had of deploying Ethereum, you get the same thing with Corda, so that it's as easy in onboarding. We don't want to have any obstacles for our partners.
Obviously, there seems to be a sort of advanced relationship between R3 and Microsoft. Are there any discussions, and this could be a question for R3 itself, of actually running the whole R3 net on Microsoft, on Azure, instead of everybody and the participants all having to boil your own nodes and run your own network? Why not just do it all on Azure? I'm sure as the Microsoft guy, you're saying yes, obviously.
Sure.
But it'd be interesting to hear from R3 whether that is a possibility.
I'll step on that. So yeah, obviously, I think what we're seeing at this stage in particular is people are using public clouds. For proof of concepts, it's a no-brainer. You immediately go to a public cloud. The majority of the activity we've seen actually has legitimately been on Azure. I think Azure's made some incredible inroads to become kind of the enterprise system. now, as you build out a production network, we're looking particularly to Azure because of its high availability, its fault tolerance, et cetera, as an environment for things like notaries and things that we would run on the behalf of other people potentially. So it's a great environment to architect that. However, I think that if you look at eventually when these networks get built out, you should be able to run your node however you run your node. So whatever public cloud you choose, on-premise, et cetera, and they should be able to participate with other nodes on whatever network whatever infrastructure they run on. So that's probably a good way of not answering it. Absolutely. Yep. So sorry for those who didn't hear that. You can connect your node to however other nodes are running in their node, whatever network infrastructure they're using. So and you'll see more from R3 in the future here around Azure templates as an example. So building up networks with templates and such, and then deeper integration into Azure itself to take advantage of these services. And then, of course, you saw in Cocoa, we were part of the announcement there, so we're also doing work with Microsoft and Cocoa. Probably one more question.
Hi. First of all, I will say I find it kind of funny that you were showing all those Oracle nodes up on your crypto there, and so you're showing Oracle how to build databases. I like that, so that was quite funny. But basically, we saw earlier on the point about the notary, where R3 showed how they use the notary to solve the double spend problem. If we're forgetting Corda for the moment, if, say, you've got two of these other frameworks that are coming into your ledger, how are you going to solve the problem of double spend?
Right. So that would depend. So you're saying if you have multiple two separate frameworks talking to the same network. Yes.
Say, for example, someone from IBM using IBM Fabric is talking to someone using Quorum and trying to do a transaction.
And they're using a Cripple as the middle?
Well, the way the drawing seemed, it seemed that you had a set of adapters that allowed those things to flow, so it became a DLT or DLTs.
Oh, yeah, but it's using a Cripple as an intermediary.
Yeah.
Yeah, if you're doing like asset transfer from one chain to another, it does the asset locking and moving, so you can do that. I think probably you're talking about sort of, so this is one scenario where you'd have to be a ledger constraint that would prevent, because Cripples have unique identification, and you can only accept, like Ethereum, you use function modifiers and other languages, you would prevent, especially if it's a contract Cripplet, only the Cripplet can actually write to that address. So that would prevent anyone else, another Cripplet in a different framework, writing to that. You do get into some scenarios when you talk about pairs and rings, but you still only persist your truth once. I don't know. There's probably a scenario we'll come to at some point where we have to figure out the double spend, but we're assuming, that's the ledger's responsibility, the double spend piece. If we do something that runs afoul that causes that, then we'll change our architecture, because that's really the ledger. We're not trying to do what the ledger does. That's not what Cripplets are supposed to do. We're not saying do your transaction logic at the actual transfer of ownership down there.
If you did a transaction across, both ledgers would be updated, basically, is what you're thinking.
Yes, that's actually a feature, right? Yeah. Yeah. I think so. You would actually see that running that transaction across. That's one of the features that people say I can have my logic, my storage persisted to two separate ledgers at once. So. All right.
So I think, so Marley will be here for a little while, I believe, at least at the break.
Yeah, a little bit.
So if you guys have other questions to Marley, grab them in person. We're at the optimistic clock. We're actually a little bit over. So I think we'll take a break. So thank you very much, Marley. Very interesting stuff. I know there was actually a lot of ideas. So.